Good afternoon, Professor Cholula. We speak to you, the student Ruslan Mejia. In this opportunity, I talk about the laboratory number 4, 5, and 6 is Airways GPS, landing gear motor, and finally is the charge system. Is analysis of faults. Well, first I choose the GPS in conclusion where the processes performed in the last three laboratory practices are very essential because since these procedures can be carried out daily during maintenance work, specific avionic category which is based on the wiring system and the other components. It is analyzed at that operation of many electrical components and electronic systems depends on this to be deployed. Now the applicability of the airways in this part of GPS was important because the installation and the interfaces of these systems were verified in their respective diagram, although physical circuit was not mounted. Um, this interface is given with the CDE, the instrument to from, and then the instrument NAT flag, and the OBA data, and message announcers, and the only instrument with which an upcoming test could be done in the aircraft is the RMI, because the RMI is present in the instrument of the aircraft. It's the um, it's a viable instrument now in the aircraft. And the final analysis of the first part of the GPS system is in this laboratory we check the connections and check the diagrams. Only this. Okay. And the final analysis of the result obtained of the airways in the GPS, it was determined that the airway system is essential to the deployment of the maintenance work in regard to the wiring of the aircraft. Since this involved the correct functioning of the electrical and electronic systems, because in the addition to this, it must always take into account the proprietary procedures for the execution of the assembly of an electrical circuit, which in turn requires that we warnings and precautions to ensure the proper performance of the work carefully observed. Okay, I pass to the second part, is the charge system. Well, this system have three principal components. One is the battery, two the voltage regulator, and three is the alternator. First, the battery provides the electrical current to the energized winding rotor of the alternator. Two, the voltage regulator controls the flow of an electric current produced by the alternator. And three, the alternator is a stator, a rectifier, no, an alternator have a stator, a rectifier, a rotor, and a voltage regulator. As analyzed the function of this component, this component generates electricity in the following way. First, the rotation of the engine crankshaft couple transmit movement to the alternator through the rubber belt. Then the rotor inside of the alternator rotates inside the stator windings. The rotating movement of the rotor generates electricity in the form of alternating current, and finally the rectifying diodes converts this alternating current AC to direct current DC. The battery, in addition to being recharged, the alternator provides power to the regulator so that there is excitation and the charging process starts. It is also a charge compensator, which allows to a desirable value to be maintained in the electrical system. In the system, this component delivered 12, 12, 12 VDC and receiver or change 14 VDC. Once of the basic operating principle has been known, a fault was simulated in the system, so data can be identified according to the analysis performed according to the operation of the system. But failure were based on the fact that the battery was not recharged correctly. Okay, the system, the current provided to alternator is 12, but the alternator have 12 is bad. Okay. This was determined because using the multimeter it was noted this fault that 14 BTC that were initially delivered to the battery. In the first instance, it was generally determining that the problem originated due to the malfunction of the alternator. Since it did not generate no voltage for the battery charge, however, during the deployment of the time of the laboratory, it was not determined which was the core failure of the equipment, right? And for which the schematic diagram of the system was reviewed, identifying that the failure occurred due to the high electrical resistance on the ground. The fall of tension occurs as the result of the increase in resistance. We have here the fall number 1, high resistance ground. And it was finally terminated thanks to the revision of the schematic diagram of the system. And that is the lost voltage of drop with the two high resistance on the ground point of the generation ground. Okay. Finally, we have the first part of the landing gear motor. Well, the landing gear motor is a component of the landing gear system on the retraction system. Well, the retraction system have a electrical motor and the transmission assembly, circuit tube assembly, and push-pull cables for the each main gear on the push tube that nose gear. According to the diagram, the limit switches are installed in the system to shut off the motor when the gear is fully retracted. It's fully extended, right? Well, it's fully extended or retracted. Okay, these switches are connected in the turn sum operation indicator lights, which are located in the panel of instruments. Okay, the landing gear selector switch is placed in the up position, activating the retraction, right? The retraction motor. Okay. Well, when the traction motor which operates the transmission, the retraction transmission pushes heat torques forward, which the pulls the main landing gear cables and pushes the nose gear retraction forward. Okay, and the retracting the landing gear when the gear is fully retracted to gear of the limit switch stops the motor. Okay, and the amber gear up indicator light on the instrument panel lights is purple. Okay, the landing gear selector is which in the instrument panel is which in the placed on the down position, operating the motor and the traction transmission. The transmission pulls the torque the arms back which the push of the main gear cables and the push of the nose gear tube extending the landing gear. Well, when the gear is fully extended, the gear down switch stop the motors and the green gear down unlocked indicator light of the instrument panel lights. Okay. Once the basic operation was known and the component of the aircraft was removed, for which common tools were used in this procedure. After being removed, it was analyzed first according to the diagram. We have a diagram of the functionality of the all system of retraction. Okay. Well, so that is connection points of DINDAS brake cables were in the defined coil. To verify the status of the disconnection, a resistance measurement test was made for this diagram was taken into account. Okay. Well, part of this diagram, I mentioned it in my report. I mentioned the components analyzed, the specific components analyzed in this first part. We first analyzed only the motor and the brake coil. Okay. Well, okay. Well, we have measurements of resistance of the cables. Well, we have the cables on the ground wires of the brake coil motors is in one cable. It's a ground. According to the diagram. And the measuring of this cable is 1.25 ohms. Okay. and the green motor cable and the brake hold cable is in one cable, is united in one cable, is 1.25 ohms. Yeah, okay, sorry. On the other hand, the situation of the motor, situation of the motor turning points were also measurement. This is a red and yellow cables of the motor. Okay, the measurement of the network of the uh, of the yellow cable is 2.66 ohms, and the black cable is no on the green on the black cable is at 2.6 ohms. Well, okay, according to these measurements, it was possible to verify that these connections are in good state of operation. Okay, and when the first process was analyzed, however, everything is prepared for carrying out the operational test of the element installing of the aircraft in the next laboratory practice. The final conclusion, it was determined that this was a possible to verified means of our system measurements, that this equipment, called landing gear motor, was operative in two connection points. That is, a connection point to the engine and brake coil were identified. Only these components. Okay. However, the other operational tests on the aircraft could not be performed due to the fact that some components were still not physically recognized. For example, the landing gear solenoid it's recognizing the aircraft, but is not removed of this. Okay. For this reason, this test will be performed on the next laboratory. Is all for this opportunity. Thanks for watching, Professor.